Starting chapter 6 today on ratios. The definition that we have is a ratio is comparison of two quantities by division. And when we compare two numbers by division, Riley, what does it look like?
Fraction.
It looks like a fraction typically when we're talking about that. So if we talk about 4 out of 5 students passing the test, we could write it like that as a fraction. And what's another way that we might express a ratio?
With colon.
With a colon. So you might say 4 out of 5 students and make it look like that. Are there any other ways?
Probably.
Sometimes we just use the word 4 to 5. The ratio of students who pass the test compared to the number of total students would be 4 to 5. Now, those are common ways, and you might especially see them written this way on standardized testing. When you take the Explore test or something like that. But when we're doing ratios in this class, I would like to see them written as fractions. Because as we work with ratios, the easiest way to manipulate them and work with them, as we're going to be doing some things in future units, will be to have them written as fractions. Plus, we've already been working with fractions all year, and that just, the rules apply. So that will be the best way to write it. Some things about ratios. Ratios, first of all, can be expressed as part-to-part relationships. And part-to-part relationships, we might talk about the number of gray dots compared to the number of red dots. So if we compare the number of gray, that's 8, compared to the number of red is 12. For every 8 red dots, we have 12. For every 8 gray dots, we have 12 red dots, is what that would mean, a part-to-part comparison. We also can have part-to-whole comparisons or part-to-whole relationships. And in that case, we would talk about the number of gray dots, which is 8, compared to the total number of dots, which would be 20. Okay? Can you see the possibility for some confusion? Oh, I wrote 12 again. See there, I'm confused already. Can you see the possibility for some confusion when we're talking about ratios?
Yeah.
We have to know what's being compared. Are you comparing one part to another part? Or are you comparing one part to the total, to the whole number? Does that make sense?
Yeah.
Okay, so if we're talking about part to part and part to whole, we also can, occasionally you'll have a problem where it sets it up for some reason in this way, the whole number to a part. And in this case, you might just hear it might be worded something like, for every 20 dots, 8 of them are gray. And it would look like that. For every 20 dots, 8 of them are gray. That's probably the least common way to write a ratio, and one that we probably won't spend a whole lot of time on, but every now and then you might see it worded that way. Once you have your ratios established, whether it's part to part or part to whole or whatever it is, you have to put it in simplest form. Okay, so here we had part to part, it was 8 gray compared to 12 red, and so as simplest form it would look like 2 over 3. So that would mean for every 2 gray dots, there are 3 red dots. Okay, put it in simplest form. When we had part to whole, we had 8 gray dots compared to 20 total dots.
2
So that would be 2 over 5, which simply means that for every 5 dots, 2 of them are gray. And then with the whole to part, the good thing about that is if we had 20 over 8, you know how it simplifies already. It's going to be for every 5 dots, 2 of them are gray. Okay. All right, let's look at some examples. Express the ratio 10 roses out of 12 flowers as a fraction in simplest form. Explain its meaning. What type of ratio is this? Austin.
First is 10 out of 12, and then simplified, it's 5 out of 6.
Okay, and what does that mean? 5 out of 6 means what? Riley?
Well, I just had it. 5 out of all 5 Out of 6 flowers, 5 of them were
Okay, out of 6 flowers, 5 of them are roses. There are 5 roses for every 6 flowers.
Yeah.
Okay, Kari?
So it's part to whole.
This is a part to whole ratio. That's exactly right. Because it's comparing part of the flowers, the roses, compared to the total number of flowers. Could we set this up as a part to part ratio?
Yeah, because it would be 2.
Okay, so there are 2 flowers of some unknown type compared to 10 roses. And then we would simplify that to be 1 out of 5. So there is 1 other type of flower compared to every 5 roses. If you're talking about if you own a flower shop or whatever, you sell for every 5 roses you sell 1 other type of flower. I don't know, maybe that's what that would be. Okay. Another example, a store found that 35 customers who came through in 1 hour, 25 were women. Express this ratio as a fraction in simplest form. Kari.
25 out of 35.
25 out of 35.
And it goes 5, 7.
Okay, and what does that mean? How would we explain that?
For every 7 people, 5 of them are women.
Okay, for every 7 customers that walk through the store, 5 of them are women. What other information can we get from this problem? We know this ratio is given to us, but what other information can we take from the problem since we know this ratio?
The other half is boys.
Well, it's not half.
I mean, the other part is boys.
Okay,
2 out of 10. 2 out of 7 are men.
okay. So if we have 5 out of 7 are women, then we could say 2 out of 7 are men, okay? Or 10 out of 35 would have been men. Okay, so there's always kind of a flip side to ratios, and something else that's some other piece of information that we can draw from the ratio once we have it established. All right. Ratios involving measurements should have the same unit rates. A unit is that label that we talked about on the last test when we were talking about yards and meters and feet and inches and those kind of things. Whatever measurement you're using needs to be, they need to be comparable units. You can't measure or compare ounces to pounds. And so if we're trying to compare 8 ounces to 3 pounds, we need to get to the same unit rate. What would we do to get the same unit rate, AY?
Do 3 divided by, 16 divided by 3. Or 3 divided by 16. Times.
Times, there you go.
Sorry.
Let's multiply, and what is that gonna get us?
48
48
ounces.
ounces, because there are 16 ounces in 1 pound. So this is not established as a ratio correctly. What we really want to have is this, 8 ounces compared to 48 ounces. And since we've got them in the same unit, we really don't even need to worry about the label. Okay, so we could just set up our ratio as 8 to 48, and then we have to simplify. So simplify it.
1 over 6.
1 over 6. And you would use this maybe in a recipe or something if you were trying to, if this ratio here was serving 10 people and you wanted to serve 20, or 15 or whatever, how would you make it bigger? So, getting it down to that same unit in the simplest form, you could find a way to increase your ingredients. All right, express the ratio. You know what? I don't even like this problem. This is not, I don't like the numbers, the way the numbers work out on this. I need to change that one. So we're going to skip that one. Go straight to your homework. And there it is. Page 269, 270, 10 through 32. 12 problems.
That's a lot. How many 12? Bingo. Roll.